Hello guys, welcome back to Maison African Motives, still on Engineering Science N1, November 2022 question paper. That is on Dynamics, section B. On question number 5, we have a question that we want to discuss here, where we are given that figure 1 shows the route Peter must take from his house to the cave. Okay, so we are given, this is the route from his house, that is from this point up to the cave at this point. Okay, so if you have to check, we are given the distance of 75 meters, 56, then 170, like that. So the first question is to determine the distance from the house to the cave. That is 2 marks for that. Okay, so you've got the distance. Take note, this is distance. So if you are referring to distance, we are referring to the distance, to the movement which was taken from the house, from the house, then throughout all the points until we reach the cave. So we are adding everything. That is the distance. All right. So that is our distance. It's going to be equivalent to, we add the first one, that was 75 meters. Okay, so we've got 75 meters plus the other one from this point here, from this point to this point, which is 56 meters. So you add 56 meters plus from this point to the last point, that's 170. So you add everything. So that is the distance. All right, so if we add everything, we are going to obtain 301 meters. Okay, then on 5.12, the displacement from the house to the cave. Okay, so this one, you're supposed to draw an accurate diagram using units. You can prefer. So in this case, I'm just going to show you that the presentation. But next time, I'm just going to try to have a question that we are going to use a ruler and everything, so that I actually show you what you're supposed to do. But for now, I just want you to understand what is happening here. For you to have an accurate diagram, you're going to choose a scale. We can just say, in this case, 10 meters is going to be represented with 1 centimeter. Okay. So when you are to draw 75 meters, this line is just a normal horizontal line. You draw your horizontal line. That will be 7.5 centimeters. Remember, we said 1 centimeter is 10 meters. So if it is 75 meters like this, it's 75 meters. So you're going to divide 75 divided by 10. That's 7.5 centimeters. The same on 56, you divide by 10. So it's going to be 5.6 centimeters. Take note, this is drawn from a north pole. You're going to have a north pole, another north pole here. All right. Then on this north pole, this is what is going, you're going to have, this will be a straight line here from your north pole. This will be a straight line. So what you're going to do is that you need an angle of 45 degrees here. All right. So what you're going to simply measure is this angle, because there's a difference. We know that the whole of this angle is supposed to be 90 degrees. So please make sure that you measure properly. This angle is supposed to be the one that you measure from the north. You measure this angle, which is 45 degrees from 90, because remember, these two angles must add up to 90. So it's going to be 90 minus 45, which is 45 degrees. So from this 45, that is where you measure this line of 170 meters, which is going to be 17 centimeters. If you divide 170 by 10, it is going to be 17 centimeters. So by drawing this line, you are now at the cave at this point. Okay, so like I said, in our next class, we're going to have a similar question where I'm going to accurately show you the diagram, how you're supposed to even measure these angles. Okay, but for now, I just want you to know idea here. Then after that, you join from the house to the cave. Okay, so you're going to join from the house to the cave. And this is the resultant that you are going to have from the house to the cave. So what you do is that you measure this distance. Okay, if you were to measure this accurately from a diagram, you were going to obtain 18.2 centimeters. All right. So the 18.2 centimeters is not our answer here. Remember, this is displacement. We want from this point to this point. This is your displacement. So the 18.2, you now get it back to the scale that you used to draw the diagram. Remember, is 10 meters equal to 1 centimeter. So what about 18.2 centimeters? You convert this to meters. So you're going to obtain 18.2 over 1 times 10, which is 182 meters. Okay, so if you do this accurately, you are going to obtain this answer direct, which is 182. Okay, and the resultant in terms of the angle is this one. You can measure from the west. Since we want the resultant angle, we can measure from the west. Remember, this is a north pole, where this is north, south, west, and east. So from the west here to the south, if we measure this angle properly, this was going to give you 76 degrees. All right, so that means our displacement at the end in this case was going to be 182 meters, all right, at west. Okay, remember this is our angle from this angle we measured from the west going to the south. So this is west 76 degrees to the south. Okay, so this was the angle that you're supposed to measure, which is at west 76 degrees to the south. All right, so that is what you needed to obtain these 3 marks. So like I said, we are going to have this typical question in another class where we are going to be actually drawing so that you see exactly what you're supposed to do. Okay, on 5.2, we are now given that Danny drops a rock from the edge of a cliff. It takes 4 seconds for the rock to hit the bottom of the cliff. All right, so draw a neat labeled velocity time. Velocity versus time, okay? For the movement, so this is a velocity time graph of the movement of the rock. Hint, use a scale 9.8 meters per second for 10 millimeters, okay? 1 second, 20 millimeters, okay? So you were going to actually have this as an accurate diagram, but as for me, like I said, I'm not going to use it as an accurate diagram, okay? But I'm just going to show you what you're supposed to do. So take note, the time is 4 seconds. So let's just have our information here. So this was 5.2. So our time is supposed to be 4 seconds. And we are given 9.8 meters per second. So this is 9.8 meters per second is equivalent to 10 millimeters, okay? That is 10 millimeters simply means 1 centimeter. Remember, 1 centimeter is equal to 10 millimeters, okay? The same thing here, time in seconds. 1 second is equivalent to 20 millimeters, which is 20 millimeters is simply 2 centimeters, okay? So like I said, I'm just going to show you what you're supposed to do. Then the rest we'll see it in another class. I'm going to actually show you everything. But for now, I just want you to see just a sketch. It's not going to be accurately drawn, but it's just a sketch, okay? So we are going to have, let's say, our velocity. Okay, so we are going to have our time here. So this is your time axis, all right? So we've got our time axis here. Then we have got our velocity axis. So this is the axis for velocity. All right, so you're going to have something of this nature, guys. This is what you're going to have. So what you do is that you are going to mark here, you're going to label this as your velocity in meters per second. Here as your time in seconds. So that's our time. So what I'm going to tell you guys here is that you are going to have the same formality of this velocity time graph. It is not going to change. Each and every question that you're going to have, this is what you're going to do. Okay, remember that if you are given acceleration, actually, acceleration is equivalent to velocity over time. So as we know that our acceleration, which is the gravitational, is at 9.8 meters per square second. For us to have this, it's on a condition where our velocity is at 9.8 and our time is at 1 second, so that we can obtain an acceleration of 9.8 meters per square second. So that means in this case, 1 second corresponds with 9.8 meters per second. That is what it means. Okay. So each 10 millimeter, you measure 10 millimeter, let's say this is our 0 here, okay? So our time, remember we said 20 millimeters represents 1 second. So it means like this, maybe this is where we have our 20 millimeters. This is going to be 1 second, okay? So this will be 1 second. But it means the difference here, according to your graph, you are going to separate 2 centimeters, which is 20 milliliters. So this is actually 2 centimeters. You measure from one to another one, 2 centimeters again, that's a 2, 2 centimeters again, that's a 3, 2 centimeters again, that's a 4, okay, something like that. The same thing on the velocity. 1 centimeter, which is 10 millimeters, represents 9.8. So maybe we have got a 1 centimeter here. This is our 1 centimeter. Maybe it's somewhere at this point. If this is your 1 centimeter, this is going to be 9.8. 2 centimeters you add, so it's 9.8 plus 9.8, which is going to give you 19.6. You add 9.8, which is another 1 centimeter, which is now 29, and so on and so on. If you add 1 centimeter, you are now at 39.2 and so on. So what it means is that these points, they correspond. It's 1 versus 9.8. It's a point, okay? 2 versus 19.6, it's a point. 3 versus 19.4, it's a point. 4 versus something like that. Okay, so this is what you're going to have. And you join your points from 0. This is 0 versus 0. So you join from 0 the points and so on and so on. So please make sure that you use a ruler. So like here, I'm just showing you a sketch like this one. Okay, so this is what actually it was supposed to be like. Okay, so let me just show you using a ruler, just a presentation. It's not going to be accurate because I wasn't using this in an accurate manner, but you're going to have something of this nature. All right, so this is what you're going to have, where 1 here corresponds with 9.8. So it's 9.8 versus 1, 19.6 here, which is versus 2, something like that, and so on and so on. Okay, okay, this is 3, and this one corresponds here with a 4. All right. So this is what your diagram is going to look like. All right. So I think it's just supposed to be like that. Okay. For any more information, we are going to discuss as we move on. Okay. 5.22. Use the graph to determine the slope of the graph. So the slope is the gradient which represents the acceleration. Okay. So this acceleration, we can just take any corresponding point, okay? So this was 5.21, then 5.22. Remember that acceleration is equal to the change in velocity over the change in time. So you can take any corresponding point, okay? This is 39.2 according to velocity versus time of 4. So the change in velocity is 39.2 over the time, which is 4 seconds. This is going, if you divide, you are going to obtain 9.8. Okay, so that's 9.8 meters per square second, or you can take any point. Okay, this is 19.6 versus 2. So you can divide these two. That's acceleration. So acceleration can be 19.6 over 2, which is still the same answer, 9.8 meters per square second. So you can take any point, 9.8 versus 1, 29.4 versus 3, like that. So any point is of your choice. You're going to obtain the same answer. That is your acceleration. Okay, so that was the typical question on dynamics, question 5 of November 2022, carrying 9 marks. So this is very, very important to have such typical questions as we revise for the final exams, which are ahead of time. That is for now, guys, from Maison African Motives, till we meet again.